In the darkness of the night, a mysterious whisper like a blade splits the sky. This mysterious and unknown presence evades even the world's most advanced air defense systems. A night that is capable of carrying a cargo that could change the course of history, but still remains in a state of ambiguity. At a cost of nearly $2 billion each, these skybirds are known as the most expensive aircraft ever built. But what is the secret of this 50-meter giant that can hide from even the sharpest radars? And why does its design look like it came straight out of a science fiction movie? In this video, we want to reveal the secrets of the B-2 Spirit. We explore the radar-evading missile that rewrote the rules of air combat. From its origins amid the tensions of the Cold War to the groundbreaking technologies that transformed it into an engineering masterpiece, and how this giant missile has disrupted the balance of global security. The Cold War. In 1975, the Cold War reached its peak. The nuclear race between the United States and the Soviet Union had entered such a critical stage that its fragile balance could collapse at any moment. Imagine air squadrons of massive B-15 bombers stationed at strategic airbases, promises that each have the potential to destroy an entire city. These bombers are either patrolling the skies or are at full alert at bases, waiting for orders to take off in a split second to play their role as the mainstay of America's nuclear shield. Their flight routes changed constantly, but often began at Shepherd Air Force Base in Texas and continued to destinations such as the Canadian Arctic, Alaska, Greenland, or even the Mediterranean Sea. These flights were part of a deterrent strategy, a clear message to the enemy that America is always ready. But there was a big problem. Croy had not given up. They had built advanced defense systems that could track these iron giants in the sky and shoot them down like a defenseless bird. Describing the situation, one of the U.S. Air Force generals said, "Sending your plane into Soviet skies is like throwing a rock at a beehive. That's when you have a big red mark on your body." ITB plan. What is left when a seemingly invincible force faces an insurmountable obstacle? The answer is simple. The whole rules of the game need to be changed. This is where the Advanced Technology Bomber or ATB program came into being. The goal of this program was to design a bomber that could sneak through Soviet defenses overnight, deliver its payload, and disappear before the enemy even knew it was there. This idea seemed almost impossible at first glance. It was like someone was trying to hide a phyllo. Engineers spent hours trying to find a way to solve this challenge. But this was not just a simple military issue. The larger goal was to maintain a balance of power that would prevent the Cold War from turning into an all-out war. It all came back to the concept of nuclear deterrence. This strategy was based on the principle that each country should have the ability to retaliate against an attack. If the Soviets thought they could completely destroy the American bomber fleet, the likelihood of a surprise, preemptive attack would be much greater. But what no one expected was that the root of the solution to this problem had been formed years earlier. An idea that was designed but then abandoned and forgotten for various reasons. So, let's go back to 1946. A year when World War II had just ended, and most Americans were busy building cars and houses and settling into their post-war lives. But someone had another thought in mind, and it was none other than Jack Northrop, whose dreams were tied to the sky instead of wheels and tools, and the idea he had in his head was a strange aircraft called the Flying Wing. Imagine an airplane that only has wings. It has neither a body nor a tail, just a monolithic, aerodynamic structure that looks like it came out of a science fiction story. Northrop believed this idea was the future of aviation. In 1947, this dream became a reality. A prototype of YB was introduced, a flying wing with a jet engine and a wingspan of 50 meters. This plane was way ahead of its time, but it had one big problem. Without today's computers to control its stability, it would be like a unicycle on a tightrope. That is, practically unreliable. The Air Force, which expected a reliable bird, was not impressed. As a result, in 1949 he ordered all YBs to be destroyed. Yes, you heard right. Completely destroy these engineering masterpieces. This decision shows how strict and ruthless the U.S. Department of Defense was in selecting its projects at that time. So now let's go back to 1978. That is, when the US Air Force launched the 8 terabytes program and was looking for a bomber that could enter the world's most well-equipped defensive skies without detection. This project was held in a fierce competition between several major defense companies, and ultimately, Northrop won the contract. Jack Northrop's old bird's wings had risen from the ashes to show themselves in a new opportunity. But this time, Northrop had decades of technological advancement and the support of the US government. A signed blank check that allowed him to make the impossible possible. But how can a stealth aircraft with a wingspan the size of a football field be made invisible to radar? And this is where it gets really interesting. First of all, we must examine the symbolic form of this bombshell. Without you, Spirit looks like it came straight out of a science fiction movie, and for good reason. The B-2 is essentially Jack Northrop's flying wing idea from the 1940s, brought to its peak. This design is not just for beauty. Every line and angle on this plane has a specific purpose. Unlike regular airplanes, which have a distinct fuselage and tail, the B-2 is a large bulb. This design has two key advantages. First, it has an extremely low radar cross-section. In simple terms, it is very difficult to detect on radar. And secondly, it has very efficient aerodynamics. This feature allows the B-2 to fly thousands of kilometers without needing to refuel. But the real magic of this aircraft lies not in its outer shell and covering. The radar-absorbing materials used in the construction of the B-2 are the real secret to this aircraft's stealth. The body of the B-2 is covered with top-secret materials that absorb radar waves rather than reflect them. This covering acts like an invisibility cloak, a combination whose exact formula is so secret that anyone who even mentions it will disappear. But the story doesn't end there. The body of the B-2 is made of smooth, seamless panels without even a single seam. The reason is that any crack, angle, or even a tiny unevenness can reflect radar waves and reveal the plane's position. Imagine the B-2's surface is super smooth, like a super sport car, without any sharp edges. The only difference is that this machine, which is the size of a large warehouse, tries to stay hidden from radar. The next big challenge is keeping this bird's wings stable. Normal airplanes have tails that help them maintain balance during flight, but the B-2 does not have this feature. Without careful control, this aircraft can easily slip or spin out of balance and go off course. So what is the solution? Using a highly advanced system called fly-by-wire, which automatically and instantaneously adjusts all aircraft movements. This system is so secret that the exact definition of its operation is classified. The result is that the B-2 can perform maneuvers that are unimaginable for an aircraft of this size. The aircraft's engine also incorporates special measures to conceal it from radar and thermal sensors. This aircraft has 4 General Electric F-18 GE100 turbofan engines hidden inside the fuselage. The air intakes of these engines are designed in such a way that they are not visible from a high angle. This design is because the air intake cannot transmit radar signals, thus minimizing the aircraft's radar signal. But that's not the whole story. The bigger threat to bombers is heat-up missiles. Therefore, it is specially designed to conceal itself from B-2 thermal sensors. The exhaust gases from the engines are cooled by special systems before being released into the atmosphere and are evenly distributed over the rear of the aircraft to reduce the thermal effect of the gases and make the aircraft more difficult to detect. As a result, B-2 flies through the skies overnight without leaving any thermal or radar signature. These advanced designs allow this bomber to operate in enemy skies and minimize the likelihood of detection. The bitumen structure is mainly made of carbon graphite composites. The style is robust and as transparent to radar waves as possible. That is, if it were a little more radar resistant, it would be almost invisible. But precision in assembly is extremely crucial. This aircraft is built in several separate parts and then assembled with the precision of Swiss watchmakers. Even if 1 millimeter of the components are misplaced, the result will be a multi-billion-dollar radar reflector instead of a stealth bomber. Unveiling the Future, November 22, 1988. When the B-2 was first unveiled on November 22, 1988, it was as if a piece of the future was shown to the world. Everyone who saw this aircraft was amazed and amazed. This aircraft truly looked like something out of a science fiction movie, but it was ready to change the rules of air warfare. The B-2 was more than just a bomber, a combination of dozens of advanced technologies that was unparalleled until that time. At the heart of this engineering feat are more than 130 onboard computers that control all of the aircraft's systems. Not only was Beaton ahead of his time, he seemed to come from another world, a unique aircraft that had no similar examples. To achieve something close to invisibility, Unveiling the B-2 uses three key methods. First, its unique and different design acts like an engineering trick and deflects radar jamming in a way that leaves no trace of itself. Second, it has a special coating on its body that absorbs radar waves and does not allow them to be reflected. And third, it has advanced electronic warfare systems that disrupt enemy radar waves and make detection more difficult. The result of this clever combination of rudder cross-sections is surprisingly smaller than that of conventional aircraft. In fact, the radar cross-section of the B-100 is about 100 times smaller than that of the old B-100 bomber. Therefore, for enemy radars, finding this bird in the sky is like finding a pigeon in the vast expanse of the sky, something that seems almost impossible. When B-2 officially took to the skies for the first time on July 17, 1989, it proved that all these designs and calculations were not just dreams on paper. This bird not only flew successfully, but also amazed everyone with its stunning performance. B-2 was the result of decades of relentless effort. From the early experiments of Jack Northrop, who laid the foundation for this technology, to the remarkable advances in the 1980s, this aircraft was more than just a new model. It was a true revolution in aviation history, a masterpiece that demonstrated the unparalleled ingenuity and perseverance of the engineers who turned this ambitious dream into reality. Capabilities and performance. Now let's talk about the capabilities and performance of this flying giant. Beyond its stealth capabilities, the B-2 Spirit bomber is an incredibly powerful bomber designed to penetrate deep into enemy territory. Let's start with the popular loading capacity of this aircraft. Payload capacity refers to the amount of weight that a vehicle, such as an airplane, ship, or car, can carry in addition to its own weight. In the context of aircraft such as the B-18 bomber, payload capacity is usually referred to as the weight of weapons, ammunition, equipment, or even additional fuel that it can carry. For example, when we say that a B-2 can carry 20 tons of bombs, we mean that its loading capacity is up to 20 people. This number indicates the aircraft's power and flexibility in carrying out various missions. To put it more simply, load capacity means how much stuff it can carry without compromising its performance. B-2 can carry up to 20 tons of bombs. That means it can accommodate about 10 passenger cars. But B-2 isn't just capable of carrying conventional bombs. This bomb fin plays an important role in the United States' nuclear deterrence strategy and is considered part of the country's core power. For everyday non-nuclear missions, the B-2 can carry up to 3.8 tons of GPS-guided bombs. That means the ability to precisely attack 80 different targets in a single flight. B-2 can also carry special weapons, such as the powerful GBUS bomb. This 15-ton bomb, known as one of the most destructive infiltrating bombs, is specifically designed to destroy fortified bunkers and underground structures. The warhead of this bomb and other conventional bombs is larger and can easily penetrate deep into the ground and destroy fortified targets. The Air Force is speaking out with this clear message. It doesn't matter how deep your shelters are, we can still find you and target you. Now let's take a look at the range of this giant bird. With a fully filled fuel tank, the B-2 can fly more than 11,000 kilometers. This means it can go from New York to Moscow and still have enough fuel to circle Red Square a few times. Now, if it refuels in the sky, its range has virtually no limits on Earth. You might think this plane should be very fast, but the B-2 flies at high altitudes at speeds of about 901 kilometers per hour. This isn't a record-breaking speed, but don't forget that the B-2 is a bomber, not a fighter. The goal is not high speed, but to approach the target slowly and silently. In addition, it can climb to a height of 15,000 meters, almost twice the height of Mount Everest, and conduct its operations from there. The B-2 spread bomber operation is carried out by two people, a pilot and a mission commander. These two people are not only responsible for the flight, but also manage a set of advanced electronic systems and are responsible for planning your mission, something that puts them in a different position than others. If the GPS fails, B-2 can find his way with the help of the stars, a capability that demonstrates the unique flexibility of this bird. This bomber is ready to operate in any weather condition, day or night. Its advanced radar system, which has always been a topic of discussion, allows it to automatically perform maneuvers such as adapting to the terrain or avoiding obstacles. But the main question is, how much does it cost to maintain such a bomber in the fleet? The price of each B-2 is about $2 billion, a figure that exceeds the GDP of some small countries. To give you a better idea of the cost of this bomber, you can buy about 500 average homes in the United States for the cost of one B-2. Now, why is this plane so expensive? The reason is due to a number of costly factors. First, the technology used in this bird is truly among the most advanced. We're talking about materials and systems that may still be classified information by the time our grandchildren reach voting age. The next thing is exclusivity. Only 21 of this aircraft have ever been built, and this rarity significantly increases the costs. Keeping it is another story. The bomber's radar-evading coating, which absorbs waves, must be constantly regenerated. In addition, the aircraft is always being improved. Today's B-2 is much more advanced than the model that was unveiled in the 1980s. In other words, it has both improved and become stronger over time. But are these huge costs really worth it? This is the multi-billion-dollar question. Proponents of the B-2 believe that the bomber's unrivaled ability to penetrate air defenses and strike anywhere on Earth justifies its cost. But even the most advanced bombers are not immune to the passage of time. The U.S. Air Force is currently looking for a replacement for B-2. This new generation bomber will be a more advanced and intelligent version of star technology. In addition to strategic bombing missions, it will also take on roles such as intelligence gathering and coordination with larger military networks, becoming the first sixth-generation bomber. The main goal of the BitTorrent is to make it smaller, cheaper, and easier to maintain compared to the BitTorrent, a topic that allows for the construction of a larger and more affordable fleet. Now, what do you think about the Beat Bomber? And would you like to see more videos like this? If your answer is yes, like this video, share your thoughts in the comments and subscribe to Secret Organization YouTube channel for more videos. See you next time.